In this lesson, we're going to be looking at the meaning of area. You know, from school, you might know that area of a rectangle, for example, is length times width. And we usually don't associate units or meaning behind this, but in physics, you know, areas have meanings, physical meanings, and this is something that we really want to explore here. We learned how slope, you can go from a position time graph to velocity time graph using the idea behind slope. So can we go from velocity time to position time? Well, let's have a look over here. The velocity time graph here shows an object moving at a constant velocity of 10 meters per second for 4 seconds. Okay, so what I want to do is let's calculate the area maybe for each second. So let's look at A, for example. Let's look at the area of this rectangle. Well, so that's between 0 and 1 seconds. Okay, so the area there is, to calculate this, you would go area 1 is equal to, well, the height is 10 and the width is 1. So the area is 10. But what we're doing there is we're going 10 meters per second times 1 second. And the seconds cancel out. This gives us 10 meters. So the area between 0 and 1 is actually 10 meters. And we can do this for different time intervals. So if we do 0 to 2 seconds, okay, maybe I can pick a different color here. If I do blue, so 0 to 2 seconds, or green, that would be this area here. And to calculate that, that would be 10 meters per second, that's the height, times 2 seconds. Seconds cancel out. This gives us 20 meters. And we could do this for C, for the first 3 seconds. I'll use black here. For the first 3 seconds, it would be this rectangle. So 0 to 3 seconds, we would have 10 meters per second, which is the height, times the length, which is 3 seconds, and that gives us 30 meters. And in the same for 0 to 4 seconds, okay, that would give us this whole area, or this whole rectangle, which would be 10 meters per second times 4 seconds, which would be 40 meters. So what we essentially have here is we have the displacement, okay, between different time intervals. And so what we're getting here is, here we're calculating the area, and what we essentially get is the displacement. Okay, so we can plot this. So in the first 1 second, we displaced 10 meters. Between 0 and 2, we displaced 20. And then 0 and 3, 30. And 0 and 4, 40. So what we're having here is now, again, a line that's of uniform motion. Okay, and we know that this is uniform motion because we have constant velocity down here. Okay, so this is constant velocity right here. So this is super important because now to go from velocity time graph to position time graph, we just need to calculate the area. Very important concept. So let's do this again, but now for acceleration, and see what kind of pattern we get. So if we look at the acceleration time graph, and we take the area here, so let's say between 0 and 1 second, let's say we want an area here. Well, that area, so we'll call it area A, would be between 0 and 1 seconds. The height is 5 meters per second squared times 1 second, which gives us 5 meters per second. Okay, if I look at the area between 0 and 3, this here, we would get 0 to 3 is our time interval. 5 meters per second squared is the height, times 3 seconds is 15 meters per second. So what we see here is that the area is giving us the change in velocity. Okay, so before we know that going from velocity to acceleration, we needed the slope. But now we see that going from acceleration to velocity, again, is the area. Okay, so what we could do is from this we can plot the velocity time graph. So 0, 0, then the first second we gained 5, and then in the first 3 we gained 15. So we would have a straight line that way. And as we learned just a couple of seconds ago, to go from velocity time to position time, we again need the area. And going down this way is slope. So how do we take the area here? Well, now just be careful because the areas here aren't rectangles. For example, this one here is a triangle. So in order to figure out what this area 1 here is, it's going to be area of a triangle is 1/2 base times height. Well, that's equal to 1/2. The base is 1 and the height is 5. So that would give us 2.5 meters. So after 1 second, we've only gained a little bit, so 2.5 meters. And we could do the same thing for the first 2 seconds. So let's maybe change the color here. We'll do 0 to 2. Well, this one, so the area 2 here is 1/2 base, which is 2, times the height, which is 10, which would give us 10 meters. Okay, so here we're calculating area using triangles because that's the shape that we get from underneath the graph. Okay, and this is what we mean later on, and when you take more advanced math, this essentially becomes, this is how you make, this is what integrals mean. Okay, you're taking the area under a curve. And so what we can do is we can say, okay, after 2 seconds we had a displacement of 10 meters, so after 2, 10, and if we kept on going for the first 3, we would get a curved or square relationship that we would expect from an object that's accelerating. So let's look at a model problem. Here's a velocity time graph for an object. Calculate the displacement after 2 seconds and after 4 seconds. So after 2 seconds, the displacement is the area under this curve. Okay, so area is equal to the displacement, which is equal to 4 meters per second times 2 seconds, which would give us 8 meters. Okay, so that's after 2 seconds. After 4 seconds, we take area 1, but we also need to add area 2. And area 2 is the displacement 2. Okay, and that would be, we can't just go 4 times 2 because this is not a rectangle, it's a triangle. So we need to do 1/2 base. The base is length 2 times the height, which is length 4, gives us 4 meters. Okay, so after the answers after A is 8 meters, and the answer to B is after 4 seconds, it would be 8 plus 4, or 12 meters.